Hi, Henk Akmans here, Supply Network Dynamics, Chapter 4, Part 3. A thoroughly cyclical industry, because that's indeed what the semiconductor industry is. Here you see that it's fast growing, exponential growth, yes, quite clearly. Moore's law is still active there, so the capacity of these semiconductors keeps doubling every 1.5 years, I believe. But on top of that, there's high cyclicality. The red line here is the percentage of change from one year to another, and you clearly see the cyclical patterns there. And we zoom in on this year, the year 2000, when there was a very high increase, plus 37%, so 37% compared to a couple of years back, and a very deep fall after that year. And this is the period that we zoom into, because this almost looked like a perfect test signal. But while it lasted, 2000, and I was around in the semiconductor industry at that time, was a wonderful year, although an awfully busy one. Now, what is semiconductors? Well, there are all around. This is these slides are from a presentation by Jan Bezemer, one of my former students, who did his master thesis at NXP and subsequently went to work there. And it's a corporate presentation, but you see they are in everything. They are really in everything, which means that they vibrate with the economy, but also increasingly so. Customers want their ICs to be cheaper, faster and better all the time, new, quicker, and at the same time the way that you saw the market wants more and faster, but the way that these products are made gets more and more complex. There's a ever increasing complexity of designs, the manufacturing base gets more and more complex, more capital intensive, there are more specializations, there's a lot of competition. This is really a global market. Most of this stuff is nowadays done in Asia. You could say you have a bigger size of the market is Asia. There's still a considerable industrial base in the US, more around the OEMs like Apple. And there are bits and pieces scattered around the world. Some of them, for instance, in the Netherlands, around Eindhoven, the former Philips Electronics campus, if you could say that. And NXP is a spin-off from Philips, as is ASML in the next chapter. Now, this is how semiconductors are made, and it's important to note not so much the fabrication. Yes, there's a fabrication. This is where the bulk of the money is. Very capital intensive, very complex. This is where the ASML machines are used for the next chapter. Then testing. A decoupling point for these chips are first manufactured on a wafer, then cut into pieces, and the pieces are left here. And when they are mounted onto something, then the supply chain is finished. What you should notice is that for a product that only in some very innovative market lasts only for a year, it takes them almost a quarter of a year, if not more, to make it. And that's of course quite difficult if you have very fast ramp up and ramp downs. We'll also see more about that in chapter 9, I think, which deals with a particular case of collaborative planning here. So that's the problem here. Now, the specific problem that we were addressing at Semiconductors around this test signal of the 2000 market boom and 2001 market bust is, why are we always late? And as we'll see, a few decades of research have been put into that.